Okay, we're going to take a look at the one we just talked about, redrawing. I'm going to leave it as is here, but if it helps you to see it redrawn a little bit differently to keep straight what's in series and parallel, go ahead and refer to those drawings. So here we have R3, R4, and R5 that we discussed were all in series with each other. So let's go ahead and solve for some of this. So each of those was in series. We can't find out what's in parallel until we consolidate that. So I'm going to take the three of these and add them up, since they're in series, for a total of 300 ohms. That 300 ohm value is in parallel with the 100. So if you take the reciprocal of 100 and 300 and add those together, you get 75 ohms for the total. That 75 is a value for this entire section of this circuit. We've taken R3, 4, and 5 in series, and then that value we took in parallel with the value of R2. So let's clean it up a little bit from there, and then we're going to look at how to compare that with what we're going to do with R1 and R6. Okay, so this 75 ohm value here is in series with these others. So with 75 being in series with these other two resistors, you can simply add those up to get your total. So 50 plus 75 plus 25 is going to give us RT of 150 ohms. So that, with our voltage total of 24 volts, we're going to be able to solve for our current as well. So if we take over here and use Ohm's law, we'll be able to see that 24 divided by 150 is going to give you 0.16 amps. All right. Now let's go ahead and switch back over to the rest of the circuit over here and look at this. So that 0.16 and that 24, I have to decide, am I looking at a series circuit or a parallel circuit for the most basic form that I buttoned down. And the last thing I did was take the three series resistors with that 75 ohm combination one, all tied down into a single value of 75 ohms, and then R1 and R6. So all three of those, they were in series with each other. So based on R1 being in series, R6 being in series, and this 75 here being in series, we can go ahead and see that, okay, the current would be the same there. Since these are series circuits, the current's going to remain the same. So I know that R1 is going to have a current of 0.16 amps. R6 is also in series. It's going to have a current of 0.16 amps. And then 75 ohms for this entire section over here, that's also going to be exposed to 0.16 amps. So let's go ahead and fill in our values here and see if we can solve for anything. So we can get the voltage drops for R1 and R6 just based on the information we have. So for R1, 0.16 times 50 gives you 8 volts, and 0.16 times 25 gives you 4. Now, as far as the rest of these, I don't really know exactly what the voltage drop is going to be for each individual resistor, but I could figure out, based on the current and the total resistance value, what the voltage drop would be across that entire section. So 0.16 times 75 gives me 12. So if I know that this 75 ohm value that represents this entire section of this circuit has a voltage drop of 12 volts, and that I can see it's in parallel, I know 12 volts is going to go this way, and 12 volts is going to go this way. If I look at the lower path for R2, there's only one resistor here. So 12 volts going to one resistor, that's going to be the full voltage drop. So that 12 volts and that resistor right there, since there's nothing in series, it's just that by itself, there's actually 12 volts at that resistor. So R2 has 12 volts at it. based on the 12 volts, we can divide 12 by 100, and that gives us 0.12 amps. Now, when we look at the rest of these, we look at these third group of resistors. Let's go ahead and erase some of this in here. We know that we have 12 volts growing in series across 3 different resistors, R3, R4, and R5. So if 12 volts is growing across all 3, there's going to be voltage drops. So that 12 volts doesn't get applied to those. But that 12 volts does get applied towards all 3 of those. So if the total voltage drop across all 3 is 12 volts, and the total of those is 300 ohms, then I'll be able to find the current in that entire section. So the current for this entire part of our circuit here, whatever the current is for the total is going to be the same because it's a series circuit. So let's go ahead and say 12 volts divided by 300. That gives you 0.04. So that entire series section of the circuit is 0.04 amps. So each resistor is going to have that current. Now I can use Ohm's law on those, 0.04 times 100, and see that each one, since they're all the same value, is going to be 4 volts. Now 4 plus 4 plus 4 is going to bring me back to my 12 volt total that was going towards that branch. My 12 volts went here also, so I can see that adding these up does give me the total that I had going down that branch. So you can see that that works correct. So take a look at this. If you already did it, compare it to what you did. If you couldn't figure it out, use this to kind of give you a jump start to help you with the rest of your problems. And if you still have any issues, we'll go ahead and look at that as a group tomorrow.